Hi everyone, my name is Tim Berry, I'm an authorised Google trainer and I want to welcome you to this Academy Primer video. Today we're going to learn all about Google Cloud's Compute Engine. So what is Compute Engine? Well, it's virtual servers running in Google Cloud's infrastructure. Let's break this down. A physical server is just a computer running some software designed to serve requests, like a web server. It contains things like CPUs, memory, and disks for storage. A virtual server is a way of running lots of servers on a single physical computer. Each virtual server and all of its component parts are now represented in software. And a cloud virtual server is no different conceptually, except now the host physical computer is run by a cloud provider, which means we have almost unlimited capacity and we can run extremely large virtual servers and run extremely large numbers of them as well. Now, when you spin up a virtual server in Compute Engine, you create what's called an instance, and you have all kinds of configuration options to choose from for your instance. The first thing to choose is your instance's machine type, and all machine types are grouped into families. Machine families are based on specific CPU platforms to provide the right kind of power for your specific use case. Some example families are E2 for general cost-optimized computing, M2 for memory-optimized instances, and C2 for CPU-intensive workloads. And again, there are other families, these are just a selection. Within each family, we have a number of machine types to choose from, and these are also grouped. So for example, inside the E2 family, we have the E2 standard group, which provides machine types with a standard amount of virtual CPU and memory, starting at 2 vCPUs and 8 GB of RAM, and going up in powers of 2, up to 32 vCPUs and 128 GB of RAM. If we know our workload is going to require much more memory than CPU power, we could use an E2 high mem type instead. Each of these machine types has 8 times as much memory as CPU. And likewise, if we know we need lots of CPU for our application, we might choose a high CPU machine type instead, where the number of virtual CPUs matches the amount of memory our instance has in gigabytes. Now this is just a small sampling of the number of machine types available. Some machine families offer up to 416 virtual CPUs and a huge 12 terabytes of memory per instance. But what if you can't find a machine type that precisely fits your requirements? In this case, you can simply use your own custom type when you create the instance, choosing exactly the amount of virtual CPU and RAM that you require. So now we've picked a base machine type, we next need to choose an image for our Compute Engine instance. The base image will be used to provide our instance with a boot disk, and this will contain our operating system along with the Compute Engine instance agent. More about that in a moment. We can choose from a number of different public images which are maintained by Google and the open source community. For example, Debian is a popular choice for a lightweight but highly capable Linux-based virtual machine. If none of these public images suits you, you can also create your own custom image with your choice of operating system and additional software. Now, in addition to your boot disk, you might want to add some extra persistent storage to your instance. There are several types of persistent disk available in Compute Engine. 3 of the most popular are Standard, Balanced, and SSD. Standard disks are the default, and these are efficient and reliable disks backed by traditional spinning hard drives. SSD disks are the fastest option, so they cost more, and they are backed by SSD hard drives. And in the middle we have Balanced persistent disks, which are also backed by SSDs, but balance cost and performance to make them slightly cheaper. Which one you choose will depend on your workload and how performant you need your access to local storage to be. Each of these options can also be deployed as a standard zonal disk, existing in a single Google Cloud zone, or as a regional disk, automatically replicated across 2 Google Cloud zones. Let's have a quick demo of creating a Compute Engine instance. So here I am in the Google Cloud console. If I go to the navigation menu here, I can find Compute Engine under the Compute section. The console will now prompt me to create an instance, so I'll click Create Instance. So here I can give my instance a name and choose where in the world I should host it. A really nice feature of this region picker is that it shows you the options with the lowest carbon footprint. Under Machine Configuration, I can choose the machine family and machine type that I want for my VM. So here are the general purpose types we were looking at a moment ago. I'm going to choose the cheapest possible option here, an E2 Micro, and my monthly estimated cost is shown here in the top right. We have a few advanced options here, such as to use Google's Confidential VM service, a feature which encrypts the running memory of your machine, and we can also choose to automatically deploy and run a container on our VM if we want to. The boot disk section is where we will choose the image that will contain our operating system for our new VM. So here you can see all of those options we've just discussed, but I'll leave this on Debian for now. We can also choose from different versions of each operating system, so I can see Debian 11 is an option, and I'll choose that. Now, an important thing to take note of is this Identity and API Access section. This is just a primer video, so I won't go into too much detail, but every Compute Engine instance runs with an identity in the form of a service account. You can think of a service account as basically a non-human user in your Google organization. Service accounts are assigned permissions and roles, so your VM and the applications that run on your VM can act with those permissions and roles. By default, your VM will use the default service account, but this has quite a broad set of permissions assigned to it. In production, it's good practice to create custom service accounts, limited to just the specific permissions required for your applications, and use those instead of the default account. Finally, we have a little firewall helper section here. Generally, we will configure the VPC firewall in the VPC firewall section, but if you are planning to have your VM serve web traffic, this is just a little shortcut that will add some network tags to your VM to allow HTTP and HTTPS traffic if you check these boxes. So now I'll just click Create. And a few seconds later, I'll get a green tick, which means my VM is up and running. I can now connect to my instance using SSH. In fact, I can do this right inside my browser just by clicking here. Remember the Compute Engine agent I mentioned earlier? Well, in addition to managing any startup scripts and other configuration options I may have set, this agent manages SSH keys for my entire project. So there's nothing else for me to set up, no keys to copy anywhere, and I can just log straight into my VM. So now we've seen the basics of creating a VM, let's have a quick look at some of the advanced features of Compute Engine. Let's talk about some special instance types we can use. Spot VMs, which up until recently were called preemptible VMs, are an extremely cost-efficient form of Compute Engine instance that offer anything from a 60% to a 91% saving over normal instance prices. Now that might sound too good to be true, right? I mean, why wouldn't you always use a Spot VM in that case? Well, Spot VMs are a way for Google to use up its unused infrastructure that would otherwise be idle. So if these resources are suddenly required somewhere else, a Spot VM can be preempted, or in other words, stopped at any time. In addition, Spot VMs cannot be live migrated like normal instances for events like host maintenance, and they don't provide an SLA. So it's a mixed bag. But if you have workloads that can survive these sorts of interruptions, things like batch processing for example, they are an extremely cost-effective way of using Compute Engine. Now, on the completely other side of the spectrum, the other special instance type I want to show you is a shielded VM. These special VMs are hardened by a set of extra security controls, such as a virtual trusted platform module, which cryptographically signs and authenticates the state of a virtual machine. Shielded VMs also offer secure boot, which ensures the integrity of the bootloader, kernel, and boot drivers to guard against malicious modifications to the VM, and shielded VMs can even provide integrity measurements in logging and monitoring systems. So we now know how to set up one very special VM, but in most real work, we'll need to manage lots and lots of VMs. And this is where instance templates and managed instance groups come in. An instance template is much like a VM itself. It's a specification for an amount of CPU and memory, as well as a boot disk, startup scripts, and any other configuration. But it's not used to create a single one-off VM. It's used, as the name might suggest, as a template by a managed instance group. The managed instance group is just another bit of configuration that references that template, along with other settings like the minimum and maximum number of instances it should create, and optional things like an auto-scaling config and policies for rolling updates. It's then responsible for maintaining the health of instances in the group, so if there is a problem and a health check fails, a broken VM can be automatically replaced. If a load balancer linked to your group starts to send more requests, the group can auto-scale up the number of instances. And managed instance groups can be regional, which means it can automatically manage the health and availability of all of your VMs, even if a single zone goes down. Finally, I just want to show you how easy it is to automate Compute Engine with Terraform. I always recommend automating your cloud deployments with infrastructure as code. So here I've got a super simple Terraform configuration, which creates a single resource, a Compute Engine instance called test VM1. I'm specifying the E2 micro machine type, the Europe West 2B region, and the Debian 9 boot disk. Here I'm also specifying a startup script to run on my VM. Let's say, for example, I'm going to deploy a Python Flask application, so I can use this to make sure all of the packages I need are installed on startup. The only other bit of config I need to have in here is the network interface. Including this empty access config section will trigger the default option to provide this VM with an external IP address. I'll first run Terraform init, and then Terraform plan to check what my configuration is going to deploy. And here I can see my test VM1 resource. So now I'll run Terraform apply to go ahead and build that resource. And here's my new VM up and running. I hope you found this video useful. Keep an eye out for more Academy Primers in the future, and don't forget to subscribe for more free cloud training. I'll see you next time.